So here's a problem that you would see in physics. A baseball is flying through the air. So here's the baseball. So if a baseball is flying through the air, it's going to have sort of an arc. And as it's flying through the air, it's going both up and to the right. So that's what this is talking about. It's got a vertical velocity, which we can represent with a vector. Vertical going up at 20 feet per second. And it's going to the right, so it's got a horizontal velocity of 30 feet per second. So there's the vector information. And then find the velocity of the ball. Well, the ball was headed in this direction when I stopped it to put some vectors on it. So it was headed in this direction, which really comes from adding together its vertical and horizontal velocity vectors. And as you may recall, that means make a parallelogram, which in this case is going to be a rectangle because vertical and horizontal are perpendicular to each other. And then this is the velocity of the ball. And so we can then use actually just right triangle. If this is a rectangle, then the opposite side has to be 20 as well. And then v squared is going to be 20 squared plus 30 squared. So that's going to be a 400 and a 900. And then take the square root of 1300. The square root of 1300. It's going at about 36. And that's in feet per second. And then, to use a little bit of trigonometry, find the angle of inclination. So find this angle in here, and we could just use tangent is opposite over adjacent. So tangent of theta is opposite over adjacent. And then take tangent inverse of opposite over adjacent. And the angle of inclination would be 33.69 degrees.